Backpack sprayers offer a convenient, cost-effective way to apply pesticides at your farm, in your garden, or on your lawn. As with the use of any spray equipment, calibration is essential to getting the treatment applied correctly. We're going to show you the basics of two methods to use for calibrating backpacks. One for treating small land areas such as lawns and gardens, and the other method for agricultural applications. Before we conduct the calibration, keep in mind that there are many techniques for backpack sprayer application. One of the most popular methods is by holding the application wand steady and off to one side, about knee-high, while moving forward. Another common method is to swing the wand back and forth in a pendulum motion while you walk. Either application method is acceptable. Just be sure to remain consistent from your calibration tests to your actual application. If possible, do a small test with water on an area like blacktop so that you can see what type of nozzle pattern is being applied, and so you can get a relatively accurate sense of how to cover a particular area evenly. Now to calibration. Let's start with the method for land areas like turf, planting beds, or gardens. This method is appropriate when you're using a pesticide that's applied on the basis of 1,000 square feet. An example from a pesticide label would be, apply this product at the rate of 2 ounces per 1,000 square feet. Step 1. On a surface similar to the treatment area, stake out a plot of 1,000 square feet. Here we'll be doing a plot of 50 feet by 20 feet. Step 2. Fill the sprayer tank halfway with water. Never calibrate with actual product, so you'll not need to worry about exposure to hazardous products while you're conducting the test. Step 3. Record the amount of time it takes to accomplish a uniform coverage of the 50 by 20 foot plot. Make sure you're using the same operating pressure and walking speed throughout. If possible, repeat the process 2 or 3 times and use the average time. Step 4. Spray directly into a container, preferably one marked with fluid ounce measurements, using the same pressure and for the same amount of time it took to spray the calibration plot. This will tell you how many ounces of product are being applied in that 1,000 square foot area. Step 5. With basic math proportions, you can then determine how much material you'll need to treat any size area. Let's try an example. Your lawn is 40 feet by 65 feet, or a total of 2,600 square feet. The label application rate is for 2 ounces of product for every 1,000 square feet. Your test plot time for 1,000 square feet is 80 seconds, and the amount of water collected in your 80-second test is 57 ounces. Therefore, your calibrated sprayer output is 57 ounces per 1,000 square feet. Now, in order to determine the total amount of spray solution needed, we'll use the following formula and cross-multiply. The math works like this. 1,000 times X equals 57 times 2,600. X equals 148,200 divided by 1,000. And then X equals 148.2. The anticipated total to be sprayed will be 148.2 ounces, which will be rounded to simply 148. To determine the amount of herbicide needed to be mixed with water, we'll use the following formula and cross-multiply again. So 2 ounces per 1,000 square feet equals X ounces per 2,600 square feet. Therefore, we'll need to apply 5.2 ounces. Let's just call it 5 ounces of herbicide for this treatment. Remember to account for those 5 ounces by subtracting it from the total amount of spray solution needed to treat the entire lawn. Because we'll need 148 ounces of total spray solution for the lawn, we'll add the 5 ounces of herbicide to 143 ounces of water. The next method is appropriate for application of agricultural pesticides that indicate the label application rate in gallons per acre. Step 1. On a surface similar to the treatment area, stake out a plot measuring roughly equal to 340 square feet, or 1/128th of an acre. Step 2. Fill the sprayer tank halfway with water. Step 3. Record the time it takes for you to complete the full coverage of the plot. Step 4. For the same period of time and at the same pressure, spray into a container with water from the backpack. Record the ounces captured. Because there are 128 ounces in a gallon, and our plot is 1/128th of an acre, we know that the number of ounces captured in the test is directly equal to the number of gallons per acre. Step 5. Divide the amount of pesticide per acre, based on the labeled rate of pesticide concentration per acre, by the GPA, again, gallons per acre, to determine the amount of pesticide to mix into each gallon of finished spray solution. Step 6. To calculate the amount of pesticide concentration to add to each tank, multiply the amount of pesticide per gallon by the tank capacity, or by the amount needed for the treatment site. Let's try an example. Let's assume it takes you 28 seconds to spray complete coverage of the calibration plot. After spraying into the measuring cup for 28 seconds, you collect 20 ounces of water. This amount is equal to the projected application of 20 gallons per acre. The product's label rate of application is 2 pints per acre. 2 pints equals 32 ounces. Divide 32 by 20, our GPA number, for a total of 1.6. In other words, each gallon of solution must include 1.6 fluid ounces of the pesticide concentrate. Multiply 1.6 by 3.5, the gallon capacity of your backpack sprayer, and you'll see that each filled sprayer tank should contain 5.6 fluid ounces of pesticide concentrate. Keep in mind when doing the backpack test, variations in pressure applied can skew the results. You'll also want to conduct the test using the same walking speed, nozzle tip, and filter that you'll be using for your application. Remember, proper calibration leads to positive results in pest management. Ultimately, that means savings in time and money for you, something we can all use a little more of.